All right, so now that you guys have got that sheet out in front of you, just a couple of things to remember here. All right, when we're using our graphs, remember that there are two different kinds: position versus time and velocity versus time. Okay, we need to remember what we can get from each type. Okay, on a position versus time graph, we can easily find out what the displacement of the object is, okay, by taking the final position and subtracting the initial position, okay, or if we were talking about the whole trip, that would be this position minus that position, okay, because remember, displacement is how far in a straight line and in what direction you have gone from your starting position, okay. We could calculate the total distance traveled by adding how much each section is, okay. We can find the average velocity by finding the slope of the best fit line, or by going total displacement over total time. Same with speed, total distance over total time. Okay, things like that. So things like that to remember for this graph. So let's just do number one here as kind of a refresher or an example. Okay, it says using the graph at right, calculate the total displacement of the object. Well, okay, my initial position in this question is 0.2 meters. Okay, because I'm right here. And my final position is 0.5 meters. All right, so that means my total displacement's final position minus initial position, 0.5 minus 0.2, okay, gives me positive 0.3 meters. Everybody follow there? All right. Now it says, what's the total distance traveled? Well, okay, I have to figure out then, how far do I go right here? 0, right, because I started at 0.2 and I ended at 0.2, so I didn't go anywhere during that part. Okay, then I went from 0.2 to 1. Well, that's 0.8 meters. And what did I do here? Nothing. Okay, it stayed in the same spot. I was at 1 meter the whole time. Okay, and then from here to here, I went from 1 to 0.5, so that's 0.5, which means my total distance traveled is 1.3 meters. Added them all together. Why? Because distance is scalar. It doesn't care whether I went forward or backward. Okay, what's the average velocity? Well, average velocity is often the best fit line, slope of the best fit line, but I don't have a best fit line here. I have sections. So instead I have to do, okay, VAV equals total distance, or sorry, total displacement over total time. Okay, so in this case, my displacement was 0.3 meters, and that took 7 seconds. Okay, when I divide those things, I should get 0.04, positive 0.04 meters per second. Okay, find the average speed of the object. Well, average speed, okay, total distance over total time. Okay, total distance was 1.3 meters. Total time is still 7 seconds. All right, when we do that, we should get 0.19 meters per second. Everybody with me there? All right, now we'll look at one that's a velocity versus time graph. Okay, also as a reminder of how these work. Okay, so using the velocity versus time graph at right, calculate the acceleration between 12 seconds and 14 seconds. Well, one of the things we need to remember here is that acceleration, okay, on this type of graph is the slope of the line. Okay, it's the change in speed over the change in time. All right, so between 12 and 14 seconds. So at time 12 seconds, we are right here. And in 14 seconds, we are right here. All right, can I find the slope of that line? I should be able to, right? I've got 2 points that are on that line. I should be able to find the slope. Okay, so the acceleration there is going to be, okay, -6, okay, which is position 2, minus positive 2, okay, and that took 2 seconds because it was between 12 and 14 seconds. So we've got -8 over 2, which is -4 meters per second squared. Right? Slope of a line on a velocity versus time graph's acceleration, because it gives us the units for acceleration. Okay, we'll talk about acceleration more this week. Total displacement over the whole trip. This was the tricky one. Okay, when we talked about this in our notes, we said that displacement's supposed to have units of meters, but on this axis we've got meters per second, and on this axis we've got seconds. So in order to get the seconds to cancel, we need to multiply this value, the y values, by the x values. In other words, we had to find the area under the line. Okay, everybody with me there? So to calculate the area under the line, I've got to get some shapes that I can calculate the area of. Well, right here I've got no area. It's on the x-axis, so I've got nothing there. Right? But I've got this triangle here that I could calculate the area of. Okay? Its base is 1, 2, 3, 4 across. Okay? And its height is -3. Okay? So -3 times 4, okay, over 2 should be -6. Agreed? All right, so the area of this first part is -6, okay, and then I've got, okay, this little triangle, that little triangle, and this rectangle that I can calculate the area of. Okay, this triangle here is 1 second long by 2 meters per second high. Okay, so 1 times 2 is 2, divided by 2 is 1. All right, then I've got this, which is 1, 2, 3, 4, 5 wide, okay, by 2 high, and it's a rectangle, so base times height, okay, should give me 10. And then I've got this one here that's only a half a second wide and 2 tall, okay, so 2 times 0.5 is 1, divided by 2 is 0.5. All right, so that's the area of that little triangle. Okay, then I've got pretty much the same things here. Find some shapes we can calculate the areas of. Maybe do this. Triangle, rectangle. Let's do this. Triangle. Yeah, I'll change that rectangle there. Okay, so I've got this triangle, this rectangle, and that triangle. Okay, I mean, it's just area calculations, right? It's just base times height, or base times height over 2. Okay, and we'll have all the numbers we need, and then we just add them all together. Okay, so for this triangle here, it is -6 tall by 1.5 wide. Okay, so 6 times 1.5 is 9, divided by 2 is 4.5. Okay, this triangle here is 4 high by 2 wide. Okay, so 4 times 2 is 8, over 2 is 4. And then I've got this rectangle under here that is 1, 2, 3, 4 wide by -2 high, so that's -8. And then this little triangle here that's -2 high by 1 wide. Okay, so we're looking at -1 there. All right, so I've got all these things to add together. Okay, is it a lot of work? Yeah, I would probably never give you one that had that many shapes to calculate the areas of on a test because it's ridiculous. It would take you too long. Okay, but we can still do it. Okay, so we've got -6 plus 11 plus 0.5 plus -4.5 plus -4 plus -9. All right, so -12 meters is our total displacement. Okay. All right, looking at that, it obviously did spend a lot more time going backwards. That's all these downward shapes than it did forwards. Okay. Okay, and then average acceleration. Okay, average acceleration calculated the same way, final minus initial over the total time. Right, stuff like that. So, okay, give you some idea. When you get to these, we'll talk a little more a bit about them. But okay, for now, let's get going on those first 4 graphs. Okay, listen up here. So this one's coming in for marks. I'm just assuming since we have so much talking and everything that everyone's good enough at this that we're ready. Okay, this is only on position versus time graphs. So when you're done, okay, the 4 position versus time graphs on the worksheet, do not move on to the velocity versus time. It was not my intention to move on to the velocity versus time until I talked about acceleration. So now you've got these that are all on position versus time graphs. Okay, now what we want out of this is you got to do some calculating with this graph. All right, simple stuff we've been talking about. Okay, question number 1 is asking what's the position at 0, 6, and 14 seconds. Well, if it's a position versus time graph, it shouldn't be too hard to figure out where the object is, okay, from that graph. Okay, number 2, total displacement to 2 seconds, 4 seconds, 11 seconds. Here's what that means. It means from 0 to 2 seconds. Okay, from 0 to 4 seconds, and from 0 to 11 seconds. You may want to write that on there, okay? When it says total displacement to these times, it means from 0 seconds to 2 seconds, 0 seconds to 4 seconds. Okay. And then number 3, the same distance travel, or now it's distance traveled for those same time intervals. All right, so from 0 to 2 seconds, from 0 to 4 seconds, from 0 to 11 seconds. Okay, and then in number 4, the total displacement between 2 and 4 seconds, okay, 4 and 8 seconds, 12 and 16 seconds. So again, your final position minus initial position stuff. Okay, and then 5, total distance traveled for those same time intervals. Okay, number 6, velocity between 0 and 2, 2 and 4, 4 and 7. Okay, so just identify those spots on your graph. Okay, and as well 9 and 11 seconds. Right, number 7. Number 7 has to do with this curved part of the graph here. So remember, we talked about that the other day, how you get the slope of the curve. You got to draw that tangent line, okay, across there. Does everyone recall that? Right? Just look at your notes. You'll have to draw a tangent line, okay, in order to solve number 7. Right? So you might just want to write tangent line beside that one so you know. Okay, and then for number 8, we're looking at totals for the entire trip. Total distance, total displacement, average velocity, average speed over the whole trip. Okay, and then 9, 10, and 11, okay, and 12, and 13, and 14 are all V equals D over T type of questions. All right, everybody follow me here? Okay, due date for this is going to be... I'll have to look at my calendar. I'll get back to you on that one. All right, that's what you're working on now, guys. Okay, get to work on it. If you focus on this, guys, realistically, you've got 45 minutes left. You could get, for sure, the first side, maybe the first side, and all the way to at least 10 done. Okay, but you got to focus. Okay, a lot better than has been thus far. No, this one, guys, you will not hand in on Google Drive. This involves, I need to see your work. Okay? Yes. Hey, guys, it's May the 12th. It's Monday. May 12th is your due date on that, guys. Okay, guys, someone just came up here and they had a good idea. I'm going to steal their idea and I'm going to tell it to the rest of you here. But something that might save you a lot of time later on this assignment would be when you're figuring out how far the object went, let's say between 0 and 2 seconds and between 2 and 4 seconds, it's not a bad idea to write that number on here. So, I mean, these aren't the right numbers, but let's say it's like 5 and 12 and whatever. If you're writing all those on there and then later on the question asks you about the whole trip, you don't have to do each one of those sections again. You already have them written on there and you can just use those numbers and save yourself a lot of time a little bit down the road. Okay? So if you've done some of these already, it might not be a bad idea to just write them on the graph so that later on you can refer back to them and use those numbers again. Okay? And it will save you a lot of time later. So it's not a bad idea.